morning children. In today's class from Unit 1 Metallurgy, we are going to discuss refining process. Metal extracted from its ore contains some impurities like oxide ore, other metals, non-metals, etc. Removal of these impurities is known as refining process. So, what is refining process? Generally, the metal extracted from its ore contains some impurities such as unreacted oxide ore, other metals, non-metals, etc. Removal of such impurities associated with the isolated crude metal is called refining process. There are various methods are available for refining crude metal. The common methods are distillation, liquefaction, electrolytic refining, zone refining, vapor phase method. So now we are going to discuss how the crude metal is refined by distillation, liquefaction, electrolytic refining, zone refining and vapor phase method. First, we are going to see distillation. Metals have low boiling point is generally refined by distillation method. We know distillation meaning boiling. Understand ma? So metals having low boiling point is refined by distillation method. Example, zinc and mercury. The boiling point of zinc is 1180 Kelvin and the boiling point of mercury is 630 Kelvin. Understand children? Yes. So this method is employed for low boiling volatile metals like zinc and mercury. In this method, the impure metal is heated to evaporate and the vapors are condensed to get pure metal. Yes, in this method, the impure metal is heated to evaporate and the vapors are condensed to get pure metal. Okay children, yes, one of the possible 2-mark question. The next we are going to see liquefaction. Metals have low melting point is refined by liquefaction method. Understand children? Yes. So this method is employed to remove the impurities with high melting points from metals having relatively low melting points. Okay, are refined. Understand? This method is employed to remove the impurities with high melting points from metals having relatively low melting points. Example, metals like tin, lead, mercury, bismuth have low melting point. The melting point of tin is 904 Kelvin, lead 600 Kelvin, mercury 234 Kelvin and bismuth 545 Kelvin. Now we can see how the crude metal is refined by liquefaction. The impure metal is placed on sloping earth of a reverberatory furnace. Yes, the impure metal is placed on sloping earth of a reverberatory furnace and is heated just above the melting point of the metal in the absence of air. When the crude metal is heated above the just above the melting point of the metal in the absence of air means the pure metal melt and flow down the earth, whereas the impurities left behind in the earth itself. Understand ma? Yes. Then the molten metal is collected and solidified. Liquefaction, one of the expected 2-mark question. Then next we are going to see electrolytic refining. It is one of the application of electrolysis. The refining of crude metal by passing electric current is known as electrolytic refining. Yes, the purification of impure metal by using electric current is known as electrolytic refining. It is carried out in an electrolytic cell containing aqueous solution of the salts of the metal of interest. Yes, it is carried out in an electrolytic cell containing aqueous solution of the salts of the metal of interest. Children, see the picture for electrolytic refining. Now we can see the principle of electrolytic refining. Generally, the metal to be refined, okay, there is the metal to be purified, should be made as anode. Yes, I mean the metal to be purified, okay, should be made as anode in the form of rod. Understand, children? Yes, then the corresponding pure metal, okay, the corresponding pure metal in the form of thin strips should be used as cathode. Yes, remember all of you, I mean the metal to be purified, there is the impure metal in the form of rod should be used as anode. Corresponding pure metal in the form of thin strips should be used as or should be made as cathode. Understand, children? Yes, then the electrolyte, okay, yes, should be the salt of the corresponding metallic salt solution. Yes, the electrolyte should be the salt, there is salt solution, aqueous, okay, aqueous salt solution of the corresponding metal. Understand, children? Yes, then the aqueous solution of the metal, okay, there is the aqueous metallic salt solution should be added with, yes, some mineral acid, okay, yes, it should be a dilute acid. Understand? Yes, the aqueous metallic salt solution should be added with some dilute mineral acid. Understand, children? For example, if silver nitrate salt solution is used as an electrolyte, means it should be added with, yes, dilute nitric acid. The addition of mineral acid is called as acidification. So the metallic salt solution should be acidified with the corresponding dilute mineral acids. Understand, children? Suppose if you are using sulfate salt solutions, for example copper sulfate solution, okay, are used as an electrolyte, means it should be, okay, acidified with the dilute sulfuric acid. Understand, children? Yes, then the electrodes, that is the anode and cathode, okay, yes, should be suspended in the electrolytic bath, containing the aqueous metallic salt solutions. Then the electrodes, okay, should be connected to battery. Understand? Yes, then when the electric current is passed between the electrodes, means the pure metal from the anode, okay, dissolves into the solution, okay, the pure metal, there is a metal of interest, okay, dissolves from the anode and pass into the solution. Yes, while the same amount of metal ions from the solution will be deposited at the cathode as pure metal. Understand, children? Yes, then we know, the impure metal is made as anode. So during electrolysis, the less electropositive impurities in the anode settle down at the bottom and are removed as anode mud. Yes, during electrolysis, the less electropositive impurities, okay, in the anode settle down at the bottom and are removed as anode mud. Understand, children? Yes, explain the principle of electrolytic refining, okay, one of the 3-mark question, okay. Yes, so study thoroughly. Now we can see how silver is refined by, okay, yes, electrolysis method, okay, children. Yes, what is the principle behind in electric refining? Yes, the impure metal should be made as anode and the corresponding pure metal should be made as cathode. Then the corresponding metallic salt solution, okay, yes, should be used as electrolyte. Okay, so here the impure, okay, yes, silver rod. Okay, yes, the impure silver rod should be, okay, made as anode. Then pure silver, okay, in the form of strips should be made as cathode. So the cathode is pure silver metal, then anode is impure silver rod. Then electrolyte, yes, here we are purifying silver metal. Okay, yes, so aqueous solution of silver nitrate is used. Okay, here the silver nitrate solution is acidified with dilute nitric acid. So acidified aqueous solution of silver nitrate is the electrolyte. Understand, children? Yes. So here the anode and the cathodes are suspended, okay, in the electric bath and is connected to battery. When the electric current is passed between the electrode, means pure silver metal, okay, dissolves from the anode and pass into the solution, and the same amount of silver ion, that is Ag plus ion, okay, is move towards the cathode. At the cathode the silver ion is undergoing discharge, okay, and deposited as pure silver metal. Understand, children? Yes. So now we can see the reaction taking place at anode and at cathode. Reaction at anode. We know at anode, yes, oxidation reaction will take place. So, the pure silver from the anode, okay, is dissolved into the solution as Ag plus ion by the loss of, an electron. Understand, ma? Okay, by the loss of one electron. Okay, yes. So here, Ag only, not 2Ag. Okay, yes. Ag gives Ag plus ion plus 1 electron. So this is the reaction taking place at the anode. Okay, then reaction at the cathode. Yes, the Ag plus ion at the cathode gain an electron, okay, and will become, yes, silver metal. Understand, children? So at the cathode the ion is undergoing reduction reaction. Reduction follows gain of electron. Okay, yes. So the Ag plus ion gain an electron and will be deposited as pure silver metal. Okay, so the equation is Ag plus 1 electron gives Ag. Here the metals, silver metals are in the solid form, then the ions are in the aqueous solution. Understand, children? Yes. Other metals like copper, zinc, okay, etc. are purified by electric refining. Explain electric refining of silver. One of the important 2-mark question. Now we are going to see zone refining. Metals which are used in the semiconductor field are refined by this method. Zone refining is generally employed to get an ultra-pure metal. Ultra-pure metals are used in the semiconductor field. Metals like germanium, silicon and gallium are used as semiconductors and are refined by zone refining method. Understand, children? Now we can see the principle of zone refining. This method is based on the principles of fractional crystallization. Yes, this method is based on the principles of fractional crystallization. Fractional crystallization means repeated crystallization. In this method, the impure metal is purified by heating the metal, then the molten metal is allowed to solidification. Yes, in this method, the impure metal is melted and then the molten metal is allowed to solidification. During solidification, only the pure metal crystallizes while the impurities pass on into the adjacent molten region. So, the principle of zone refining is, this method is based on the principles of fractional crystallization. When an impure metal is melted and allowed to solidify, means the impurities will prefer to be in the molten region. That is, the impurities are more soluble in the melt than in the solid state metal. Understand, children? Yes. Now we can see the process. In this method, the impure metal is taken in the form of rod. Yes, the impure metal is taken in the form of rod. Understand, children? Yes, it is taken in the form of rod. Clear? Yes. Then one end of the rod is heated. Okay, using a mobile induction heater. Okay, yes, this is the mobile induction heater. Yes, so one end of the rod is heated using a mobile induction heater, which results in melting of the metal on that portion of the rod. When the heater is slowly moved to the other end, means, yes, when the heater is slowly moved, understand, when the heater is slowly moved to the other end, means the pure metal crystallizes. Okay, yes, the pure metal crystallizes while the impurities move on to the adjacent molten zone. Okay, the impurities move on to the adjacent molten zone. Okay, children? Yes, clear? When the heater is slowly moved to the other end, means pure metal crystallizes while the impurities will move on to the adjacent molten zone formed due to the movement of the heater. As the heater moves further away, means the molten zone containing impurities also moves along with it. Understand? As the heater moves further away, means the molten zone containing impurities also moves along with it. The process is repeated several times by moving the heater in the same direction again and again to achieve the desired purity level. Yes, this process is repeated several times by moving the heater in the same direction again and again to achieve the desired purity level. This process is carried out in an inert gas atmosphere to prevent the oxidation of metals. Yes, to prevent the oxidation of the metals, the process, okay, the zone refining process is carried out in an inert gas atmosphere. Okay, children? Yes, already we discussed. Metals which are used in the semiconductor field are refined by this process. Yes, what are the metals? Silicon, germanium and gallium. Yes, understand, children? Yes, it is one of the important 5 mark question.